Hello and welcome to another tutorial. So this time we are going to be continuing to add to our spaceship project. So previously we've gotten it built up for being able to move around, having some effects going. We also got stuff added in there for being able to have the spaceship roll based upon thrust and, importantly, being able to correct that roll so that it could auto level itself out. So what I want to take a look at this time around is firstly a bit of an auto landing system. So it being able to automatically land, and then alongside that want to then set up so that we can actually have a first person character that can wander around and can enter the spaceship or exit it. So I want to be able to be switching between the different control schemes that we'll be encountering. So that's going to be the focus for what we get set up. So first thing is we need to get auto landing happening. So to begin with, I'm going to position the spaceship 50 meters up in the air. So the process of auto landing is going to be quite similar in many ways to the auto leveling that we did. So it's going to be following a similar process there. So what we want to be doing, if we think about this, we need to know a height above the ground, which, well, we already have that. So we've got height above ground information. So when it's auto landing, we want it to bring that to 0. Now we need to, similar with the auto leveling, we had to look at not just the actual error, the actual value, but also looking at the rate of change there. We want to do the same here, because if we just have something that's a very, very basic controller of just, oh yeah, we'll just set a thrust based upon the distance, what that's going to result in is the spaceship just going and slamming into the ground, which isn't great. We want this to be a gradual, slow landing that's happening. So that's what we're going to get set up. So a couple of things that we want to be able to do for this. So I'm going to set up here, we'll put this into a separate section, auto landing. So I'm not going to set up the control scheme for it yet. That will be a thing that I do end up setting up. But for now, what I'm going to do is just actually make it that there's just an option here. That'll just make it easy. I'll default that to true because this isn't going to be a permanent one. So the idea will be we can actually switch auto landing off and on. But for now, we want to just have it that we'll force it on and we can control it in the inspector. Just to test, makes it quicker and easier for testing it, and that's an important thing. So auto landing, that should have a maximum altitude, probably actually an altitude range. We probably want to have it that we're above a certain height or below a certain height to actually have it be kicking in. So what I'm going to do is have a float auto land min height, and we're going to set that pretty low, like 25 centimeters. And then the maximum height, that is going to be, we might say that it has to be within 100 meters of the ground for it to be able to auto land. So we don't want to completely eliminate all of the components of flying it. We want to have that there is still work that the player is having to do. So in this case, we'll just have a height range there. So, okay, the two things that we've got then that we probably want to look at for controlling this, well, height above ground is definitely one of the things. So we're going to need a auto land and our distance influence, which I'm going to default to 0. Then we want to also have something where we're looking at our speed, and in particular the vertical speed, because that's going to allow us to control and manage that speed. So auto land, let's call that speed influence. And again, we'll set that to 0. The other thing is when we're landing, we can for a time go quite a bit faster. It's really when we get quite close that we want to make sure we're slowing down a lot more. So I actually want to be able to control the target speed that we're aiming for over, based upon the distance we are from the ground. So I'm going to use an animation curve for that. So this is going to be our target velocity essentially versus distance. So target speed versus distance. So that's good. So we've already got stuff like velocity, height above ground. So height above ground, what I want to do is, because I want to make sure I've got the very latest version of that, so I want to make sure it's really, really up to date. I'm going to actually move this to fixed update. And because I'm doing it in fixed update, we're doing stuff with rigid bodies. Rather than using transform position, I'm going to use linked rigid body position. That's going to give us a value based upon where the physics objects are. So that's an important one to be making sure we're doing there. So that's good. With the current velocity, well, that we can actually track that up here. So then we can check, well, if AutoLand is enabled, and we want to check that our height above ground is greater than or equal to the min height and that it is less than the max height. And perform AutoLand, perform auto level. Okay, so the process here is actually going to be a fairly similar formulation to what we used here, where we're scaling based upon our influence factors and where that's going to correspond to working out a thrust. So that's going to be the plan there. So what I'm going to do is firstly we want to work out our target velocity. So our target velocity is AutoLand, so target speed. We evaluate that. So we're going to make it that this is based upon the height above ground divided by the max height. That's going to give us a value that's in that 0 to 1 range. So this is going to be the target velocity. So now we can then work out our thrust. So our AutoLand thrust, well, we first use our position error, which is the height above ground. We multiply that by the distance influence, and then we're going to add to that. Well, we want then the error in the velocity. So essentially, what is the difference between our target velocity and the current velocity? Now that target velocity, we'll map that as, we'll remove sort of the negative component from it because the target velocity will actually be down. So I'm going to make it that we'll build the animation curve there as 0 and positive values. So we'll put the negative in here. So then the velocity error is our target velocity minus our current velocity, and in particular, our current velocity in the y-axis, which for that can go linked rigid body velocity dot y multiplied by our AutoLand and our speed influence. So, we're doing target minus our current. If we got the sign of those around the wrong way, all that will change is the sign of this factor here. So that's something we can easily adjust if we needed to. So, okay, that gives us our thrust calculation there. I want to make sure that thrust is still within the valid ranges, because if we mess up too much, it should actually still be able to crash if we get this really wrong. So we don't want to be able to apply more thrust than we actually are capable of. So AutoLand thrust, we're going to clamp that between minus of our max V force and max V force. That just ensures that it's going to be in a valid range there for us. So we've calculated the thrust. Well, let's go linked rigid body, add force, vector 3, well, it won't actually be vector 3 up, it will be based upon our transform.up. Now this is assuming that auto leveling is happening. That's something where I think what I would do, will perform AutoLand. I'm going to put this here. And what I'm going to say is if auto level is enabled, or we're performing an auto land, because auto landing should actually do some leveling off as well. So that way then we can use transform.up multiplied by our auto land thrust. And we're doing this the exact same way we add thrust here. So force mode dot force. Now, this won't actually fire the thrusters because we're not applying an input, but that's okay. We'll be able to sort that out. So, okay, let's take a look then at how this goes. So, at the moment, we haven't really configured any of this stuff. So what I'm going to do is start off with standard S-curve. Now, when we're pretty far away, I want us to be able to, the spaceship to be able to drop at quite a large rate. So I'm going to say that at distance will allow 10 meters a second. So about 36 kilometers an hour descent rate, which is pretty decent. We could possibly increase that further. Now at the moment, when we run it, it's not going to work particularly well. When we run it at this point, it's going to just plummet straight down. There's no control happening. So what we want to then do is let's start adjusting our velocity influence first. The reason being is that the velocity influence is what's going to rein it in. So if we get that as a decent enough value, it's going to actually allow us pretty much a slower descent just from it alone. So I'm going to start that out at, if we look at the values we were using in other places, I'm going to go for starting at 1,000. And we'll see what that does. What I'm hoping to see, and this will tell me if I've got the sign of this correct, is that the velocity doesn't increase as much as it did, that it seems to have some braking happening. So we'll run this. So you can see it definitely is slower, and it does reach a cap there. So that's giving it a much better control. I generally go for increasing or decreasing these by pretty large amounts. Early on, do pretty large chunks. So that, even slower. That's pretty good. Going to ramp that up a little bit further. I want it essentially to the point where it's almost hovering. Not perfectly hovering, but almost hovering. So with that, pretty slow, steady fall rate there. So that's good. Because what I then do is, so the speed influence is applying the brakes essentially. The distance influence is going to be the one that is going to push it down a little bit. So what I'm going to do is distance influence. Let's test out a couple of values for that. So let's initially test 1,000. Just because we found, other ones we needed to, this sort of parameter was typically so that it's actually going even slower than it did when I had that as 0. So that's what I'm looking for to know that the sign of something might be wrong. So if I try then minus and run that, then rapid descent rate. So we're seeing we're hitting like the 10 meters a second. It's descending much quicker, but it's slowing and slowing and slowing. And as it gets lower, that manages to really slow down, and then it just drops right at the end, which is great. So that's looking pretty good for those values, but we'll notice the thrusters weren't firing. So that's something where we do want to make sure that we are sort of feeding that information through into the thrusters as well, because the visuals here, we want to make sure those are properly updating. So what I'm going to do, this is something where I think I would actually set up a separate variable here. So we'll have a protected float current AutoLand thrust, and I'll make that normalized thrust actually. So this gets set to our AutoLand thrust divided by max V-force. Because I've clamped, I know that it's going to have to be between our -1 and 1 value safely. So that I can rely on that being between -1 and 1. Otherwise, we will set that to 0. So then I can bring this up to here as just a helpful thing for us to be keeping track of. And then when we are applying the visuals, so our y-axis, this is the one that's going to be affecting vertical force. So with this one, what I would do is working y thrust is input thrust dot y plus normalized AutoLand one. So then just all of these ones here where I was using that, I change them over. So everything will work pretty much the way that it was. Means if I'm also applying some thrust as well, that it's going to visually give me the correct combination there for it, which is important. So let's test that out. What I'm expecting to now see is it auto-lands, but we also see the rocket firing, and we see those visuals there. So if I just pause it, and we can take a look. So we're not seeing that currently, so we do want to just check and make sure that this is getting, and so this will be the thing that it's running into, where because the thrust, I'm not applying anything, it won't have actually changed. So I'm going to change this to AutoLand. We'll actually make it that mathf approximately. So our current normalized one, and checking against 0. So if it's not 0, not approximately 0, then that can force an update as well. So let's test that out. So now we can see it did fire a little bit at the top just to get us moving, because we didn't start with initial velocity, but the thruster's firing. And we can see it's working quite nicely there. It'll land. And then it hasn't quite stopped, so that's something where what we would want to do is just likely, because we've now landed, our thrust there hasn't fully updated. So we're probably going to need to change this a little bit, where what I might actually do is this. I can actually bring this up here, and we're going to actually have our stuff where what we'll say is previous working y thrust is 0. We'll do an update here. So we're just going to have to check both conditions. It's a little bit more than I would normally sort of like to do, but it's not going to be a huge issue. And then we'll bring this up to here. Actually bring that down and make this protected as well. Let's test that out. It's a minor visual thing, but I think I just want to have it that it does properly shut off the thrusters when there's nothing happening there. So we get a little bit of push there. I'm going to load up in the scene. That's looking good. Thrusters firing really nicely. About to land. Successfully land, and the thruster has stopped. Okay, so let's get in the ability to turn our auto landing off and on. So first thing we've got to do is we've got to update our actions. So we'll go to our spaceship, and what we're going to do is, we've already got our options here for horizontal and vertical. Our player, something like the fire action is potentially something we could use from the player. We can also just set up a simple one here. That will be toggle AutoLand. And what I'll do is for the gamepad, we've got a few different buttons that we could be using. I'm going to go with on the Xbox controller, the A button, which will be button south. So gamepad, and I want to, that should do the trick. For keyboard, let's add in a binding, and we might just make it the L key, keyboard and mouse. So that will be on toggle AutoLand. So that gives us a new function that we need to listen to. So go back to our script here. We'll have protected void on toggle AutoLand. Just get the naming exactly right. Because that's the thing, if you get the naming wrong, you don't get any error, it just doesn't happen. So AutoLand enabled, we'll flip it, and we'll do that if value is pressed. So what I'm going to do is test this out. What should happen is this should mean that, and we'll leave the setting here still public just so I can easily see, because what I want to hopefully see is that it can start auto landing and I can turn that off. So it's auto landing. So press the key and it does properly turn it off. So then we're up, we'll go up a decent height, toggle auto land on. We fall at a pretty decent rate, which is to be expected, but the auto landing is happening. So that's great. We have the ability now to perform the auto landing. So what I'm actually going to do is I'm going to have it that this functions as this is the capability to auto land. And I will then change down here a protected bool perform auto land. So the ability to auto land will always be enabled, but we have to actually toggle it on. So this will toggle perform auto land, and it can only do that if the value is pressed and if auto land is enabled. Otherwise, no auto landing. And that then means down here, we use, I'll rename this auto land in progress. Maybe auto landing. Just want to avoid it getting too long the line, so I'll actually bring this here. And auto landing. And now, we should, when we start, we should actually be falling immediately. And then when I press A, so we're falling, there's no auto landing currently, but I press A and the auto landing kicks in, slowing down my descent, which is good. And I can still thrust and move around as well. So it means I've got that still available to me. But it will nicely just slowly drop me down, which is great. Now, once it's landed, if I try and take off, see that I run into issues. So that's something where what we want to do is, as a final thing, if we're auto landing, we want to check down here. If we have, so if we're auto landing, that's already checked those distances. But it's possible we have now passed out of those distances. So we want to check if perform auto land and, well, actually, we can possibly just get away with setting perform auto land to false. I may make it though, I think it would be good to check that the height above ground is less than the auto land min height. think that's probably good just to do that, so it only switches off when we actually have landed. Otherwise, the system essentially stays armed. So if we go too high, it can still actually activate. So that's good. Auto landing is turned on. Coming in for a landing, a nice gradual, graceful one. Certainly more graceful than I usually manage with this. So it'll land. Auto landing's now turned off. And I can take off as normal. Now let's give this a bit of a stressful time. And I'm going to go up pretty high. Now this may be a little bit beyond the capabilities of the auto land, but we'll find out. So it won't kick in until we hit the point where we're below 100. And it probably, yeah, that was much more than it was going to be able to feasibly. Essentially, what we did is we hit a situation where the thrust needed was more than what we were actually capable of. And that's reasonable. I'm okay with that actually being a scenario we have. So starting off with a bit more of a level speed, but still above the 100. I've turned on auto landing, and with that, it does actually correctly land us. Now, we could potentially try and really mess it up. One of the things I want to do is try and auto land onto that platform. So we've landed. Let's kick up here, and I'm going to, from this height, turn on auto landing and hover over this, and see the velocity immediately drops quite a lot. And it does that, and if I do that, it's going to have a bit more of I did kind of curse it a little bit with that. But when we moved over the platform, our velocity dropped a lot more, which is what we expect to have happen. So that's great. We've got a solid auto landing happening. Now I want to be able to have it that we can switch between a first-person character and the spaceship. So to do this, what I'm going to do, first I'm going to import a package. And I'm going to import my character motor package. So this is the latest version of the character motor. So we're going to import that, and we're going to add the character into the scene. Now that immediately is going to make things a little bit more complicated. So our character motor, I've got the prefab, bring that in. I'm going to return the spaceship back to the ground as well. And I'm just going to move the player character so that they are in view there of it, so they can see it. We want to make sure they are also on the ground, which I think with the height of the ground probably means they need to drop like to -1.6. So there we go. Player characters there. Now, if I just try and run this, this is not going to work so well. So I've got the player character, and if I select the player, we look at the position here, the player isn't moving. The spaceship is, but switching between these is going to be a bit tricky because we've got multiple player input systems. We've also got multiple cameras we need to switch between. So what I'm going to actually do for this is I'm going to set up something where we have our input dispatcher. So its job is going to be sending the input to the correct thing. So first thing I need to do is, if we look at the character motor, they have their own input config. And they've got a bunch of settings here that we don't have in this other player one. So this player one has got all of these. This one's just got the default. So what I'm going to do is in the input config that the spaceship is using, I am going to delete player. I'm going to go to the first person controller one. I'm going to copy player and paste that in. That's something that we can validly do. Because what I'm then going to do is that player controller, well, they're going to lose that input config, or at least they're not going to use that input config. So this player, I'm going to turn off their player input script. And I'm going to go to the spaceship. I'm going to copy its player input, and that goes onto the input dispatcher. So paste component is new. So the input dispatcher is going to send stuff to either the player or the spaceship. So the spaceship's player input, I'm also going to turn that off. So then we set up our scripts here. So we're going to have a script. This will be our input dispatcher. Going to add this on. And so a couple of things it's going to need to do. Firstly, it's going to need to be able to talk to our different ones. So that has Visual Studio. That was weird. Let's try that again. There we go. So it's going to need to be able to relay stuff to the different ones. So what I'm going to do is it's going to need game object, linked player. Also going to need a game object for linked spaceship. Actually, I'll just call it, player game object, spaceship game object. It's also going to need to keep track of what one's active, so that's okay. I'm going to create an enum here. Target. We'll have an unknown for just if something's, we're not sure of what it is. Then we'll have player. Then we'll have spaceship. We'll have a serialized field, the target initial target, and that's going to be set to make it the player by default. So then we'll have eTarget current target, and do this in awake, I think will be fine. We'll say current target is initial. And then we need to be able to relay things. So what we actually do is the character motor, it's got everything in this input handling section. So I want to grab all of these functions that took the input values. So all of these, and I'm going to bring these over here. And what these change to. So we'll bring in using Unity Engine input system. What these become is, well, onMove only has validity for if it's the player. So if current target is equal to player, then we do player game object, send message, onMove, value. And this is the pattern we follow for each of these. So every single one of these, that means the character motor, apart from us turning off that player input, nothing changes on it. And the same will be true of the spaceship. We'll just get all of these going for the player first, because the player has a lot of ones. The spaceship has very little in the way of inputs. So spaceship is a much quicker one to set up. So then we just copy over the names here. So crouch, everything like of that. So this just means character motor, it's receiving the same information in the same way that it did before. All that's changed is where that's being relayed through. So there's a little bit of a performance hit almost certainly with this, but not enough that it's likely to cause us an issue. And if it was something where we did end up finding it was showing up in a profiler, we could then go and change this fairly easily to be something that's avoiding send messages there. So then what we can then do down here, we bring in the spaceship ones. These are going to be almost identical. The main difference will be is that rather than talking to the player, they will talk to the spaceship game object. So we just switch that over. We also need to change this. So that works. And we update the function names. So now we've got all the function names set up, all that data should get properly relayed. We also need to take into account the cameras. That's something that we haven't yet considered because we do have Cinemachine cameras on each of them and we need to control which one's active. So I'm going to bring in Cinemachine so that I can also have a serialized field, Cinemachine camera, and we do have the virtual camera. So we'll have player camera, and we'll have spaceship camera. Because what I will do then is which ones are active is going to be based upon our current state. So player camera will be enabled if current target is equal to player, and the spaceship camera follows almost identical setup. It's enabled if the current target is spaceship. So we should be able to link this up and test this out. We can't enter or exit yet, but that's okay. We should be able to properly switch between these though, in terms of what one it starts with. So we can link up the player game object. We can link up our spaceship game object. We can, for the player camera, got that. And the spaceship camera, can actually rename that to follow camera. So what we should find is now based upon whatever we select here, that's the one that will be in control. Okay, so let's test this out. So we'll run it, and we've set it to be the player by default. And we are in the player view, but we can't move. And that's because if we see the default map, we weren't changing our input map. So that's something we do actually need to change as well. So serialize field, player input, linked input. Actually, we can make that protected because this is something that is going to be, has to be on the object. So we could retrieve that in awake, I think, quite comfortably. So I'll just do a require component, type of player input. We'll retrieve that. And then here, we'll do linked input, switch current action map, and we'll switch it to current target.toString because I made sure the names of the enum here matched up. So I'm going to also refresh inputs, just because this is a bit of logic we are going to need. So actually I might make a target changed, because that's something that we are going to be doing more than once for sure. So this should be good. We should be able to start off, and it will hopefully, whereas the player, we can move around. So that's good. Now we need to be able to switch. So what I want to have is, if we're in the spaceship, be able to, we could potentially exit. There's lots of things we could do there in terms of making that side sort of really nice. What I want to be able to do, just as a easy sort of way of testing this, is I'm going to say serialize field eTarget current target, or requested target actually is the appropriate one there for that. So we're going to say requested target is equal to that, because then we can do update and if requested target is not equal to our current target, then we do current target is equal to requested, and we do target change. This should allow me, while running, to change the setting here, and it will go then and update. So we're currently set as the player. I'm going to say, switch me to the spaceship. It switches over. I've got control of that. I can change this then back to player. And now I can move around. So we've got the ability to switch which one we're controlling. That's something where we could then set up stuff so you have to be in a certain range, we position the player. Those are some nice little bits of polish that we will add in at a later point. But for the moment, we've got this up and running really nicely. I am going to make sure we update the prefab. So again, player input, update that. We don't update everything in the prefab. We update the script. We update the bits for our camera. So essentially anything other than the, anything other than the Pro Builder meshes I'm updating, just because as mentioned, I've run into issues with that previously. And the player, that doesn't use any Pro Builder stuff, so I can update that prefab happily. And the HUD, just to make sure that's fully up to date as well. So there we go. We have our spaceship and our player. We're able to switch between them. We've got auto-landing options. We've got roll control. We've got a lot of pieces there for having this be able to move around quite flexibly. And similar to with the auto-leveling, that auto-landing, you could change that based upon things the player has unlocked. You could extend the range of that. So at the moment it's a fairly short range, but you could give them versions that work at a much larger range. These are all things that we have at our disposal that we could be setting up and doing there quite easily if we wanted to. Thanks folks, I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, really appreciated. If you got any questions, chuck in a comment below. If you're looking for the code for the project, that code is available up on GitHub, and I've placed a link in the description. As with any of these projects, you can use this code freely in any of your own projects, commercial, non-commercial ones, you're able to be using it. If you've got any suggestions for other things you'd like to see added to this, chuck those in a comment below as well. And if you're looking for other ways to support the channel, I do have a Patreon, and there is a link to that in the description as well. But until next time,